My name's Steve Muskal. I run Eidogen. I wanted to run through a couple things related to the mobile app work that we're doing, mainly because, as many of you know, the marketplace that we live in is very small, and as we try to branch out, it's important to hit a lot of the people out there who don't necessarily normally have access to the tools that we all have access to. So by show of hands, how many people have iPads or iPhones? Out of curiosity. Yeah, good number. Just threw a joke there because people used to argue that iPads weren't that important, but they're becoming necessary. We actually have a nice suite of mobile apps at this point. Listed here from left to right, iPhone, iPad apps. Some run on both, of course. Several of these are actually free, and some, of course, you have to pay a very small amount of money for. It's very interesting, though, of course, when you go from a free app to a paid app, even if it's only a few dollars, the number of downloads goes down tremendously. So the landscape of users of these apps at this point, it's well over 20,000 downloads at this point. Now that's because several are free. The ones that are paid for, we have just a couple hundred downloads, frankly. But it's interesting nevertheless. A lot of people have downloaded these apps. So I'm going to touch on a few: iKinase Pro. I won't touch on iProtein. Briefly touch on mobile reagents, and then leave it to you to look at the App Store if you're interested in looking at Reaction 101 and Yield 101. But we're covering a nice suite of territory with these apps. A key point I wanted to mention, though, up front here: the mobile devices are very powerful, but the reality is you can't store large quantities of data on those devices, and so you still need large servers on the back end. So almost every one of our apps, every one of our apps involves a mobile cloud type infrastructure. So of course you therefore need internet connection. There's a database and a web server and sometimes even some load balancers in between. We try to work with technologies that there are a lot of people out there who know how to develop in. So the LAMP technology, the Linux, Apache, MySQL, PHP is an environment we often work in for these apps. For the structure search piece, that's one of the reasons I have the opportunity to talk today here at the ChemAxon users meeting, is that we use the ChemAxon's JChem web services on the back end for the structure search piece for the iKinase Pro application. So you'll see that, well, I can't show the demonstration, but if you're interested, I can show you afterwards. And then for the drawing pieces, native to the device, we use MMDS, which is from Alex Clark, or a web-based JavaScript version of a drawing application that's called JS Draw. I'm certainly looking forward to the JavaScript version of Marvin whenever that comes out. iKinase, first app we put out there actually in December of 2009. Was the first chemistry-based app out there a long time ago now. I think when we first released it, it was about 2-3 weeks worth of availability that we had 2,000 or 3,000 downloads. It was amazing that many people actually worked in kinases. That had iPhones over Christmas and New Year's. We started charging for it, and then, of course, tailed off right away. This app, you can access targets. You can view chemical structure, activity data as chemical cards, but it's very basic searching. And it incidentally does hit a very current version of our kinase knowledge base. iKinase Pro is the application I certainly wanted to spend more time with, because it's one that allows you to do substructure searching over the iPhone and iPad. And this, of course, was what uses the JChem web services on the back end. So, of course, you can do target searching, keyword searching, that type of thing, but you can draw out chemical structures, substructures, similarity search, any kind of structural search you can think of it if you're able to draw it from a chemical structure perspective. So it's real powerful, highlighted substructures, grid views, real nice. Can't show the demo, but I was going to show you the parallel demo of the iPhone and iPad. I want to touch on mobile reagents because this is an application that allows access to literally, I think it's 6 or 7 million compounds at this point, server side. Actually, it might be closer to 11 at this point. These are commercially available, a variety of vendors. behind the scenes. It's imagine like the available chemicals world out there. It's actually a free app. You can download it. It looks like a reagent bottle. You can do some real nice searches in. We recently added QR code handling in there, so you can scan a QR code, provided it actually has either a URL behind it or one of our QR codes that actually has an ID associated, and it can automatically do a structure search based on that, assuming the QR code has that information in it. We also show the native version of the drawing app here, and this is the MMDS at the bottom, so you can nicely draw out chemical structures on the iPhone. No demo there. Again, quick summary. The apps cover a fair amount of space. I just showed the chemistry ones. The iProtein app actually surveys the target informatics platform content that we offer, and allows a variety of protein-based searches, including even modeling of sequences to structures. Reaction 101 allows you to draw out reactions, store them up, share them, and yield allows you to do a number of calculations around chemical reactions. And finally, I just want to do one last plug on kinasedata.com. It's actually kinasedb as well.com. It's primarily geared towards academics, but we do offer a version of the kinase knowledge base in instant JChem format on that site. It can be downloaded for a fraction of the fee of what we normally charge our kinase database for. But it's meant really more towards a community building environment. There's a lot of new information that is appearing in that, and we had a recent redesign, so I encourage you to take a look at it. That, I thank you, and move to the next speaker.